Annihilation of a positron-electron pair. A positron with speed v impinges horizontally upon an electron at rest. These particles annihilate and produce two photons with the same wavelength lambda, each of which travels at angle phi with respect to the horizontal. Part A. What is the condition for energy conservation in terms of m, gamma, c, and h, where m is the electron mass and gamma is the relativistic correction factor, 1 minus v square over c square parentheses to the power minus 1 half. Okay, so let's start with noting the electron and positron energy. So we have the total energy of the positron this is equal to, now the positron is moving with a speed v, so it has a kinetic energy and it has its rest energy. So the total energy of the positron will be gamma minus 1 mc square plus mc square, which will be equal to gamma times mc square. That's the total energy of the positron. Now, electron has only rest energy, which is equal to mc square because the electron wasn't moving to start with, and the produced photons will have energy. Photon energy will be hc divided by lambda, the wavelength. Planck's constant times the speed of light divided by the wavelength. So we can write the energy conservation now. So we have gamma times mc square, which is the positron energy, plus mc square, which is the electron rest energy, and we're producing two photons, so with the same wavelength, so the same energy, 2hc divided by lambda. Now you can see here, this term comes from the positron, this term comes from the electron, and this is the energy of the produced two photons, because the positron and electron get annihilated. So that's our answer to part A of the problem. Let's move on to part B. What is the condition for momentum conservation in terms of the same parameters and the angle phi? So we have electron momentum, let's call this electron momentum P is equal to 0 because the electron was at rest to start with. So this is at rest. Now we have the positron momentum. Positron momentum is gamma times mv, its speed v. So this positron is moving on the x-axis. It has positive electron charge and the same mass as the electron. It hits the electron at rest, and electron and positron get annihilated. We have two photons scattered at an angle phi with respect to the horizontal with the same energy. So if I write momentum conservation, because there are no external forces acting on the system, initial momentum x component must be equal to final momentum x component. This is telling me that initial momentum, which is gamma times mv, that of the positron, there is no initial momentum for the electron, is equal to the final momentum twice h over lambda. Momentum is equal to h over lambda, de Broglie relationship, and its x component, we have to take the x component of this, that's multiplied by cosine phi. So this is our momentum conservation equation. What is going on the y-axis? Initial momentum y component is equal to final momentum y component, and there is no initial momentum y component. Final momentum y component, we have h over lambda sine phi minus h over lambda sine phi. So we have momentum conservation on the y-axis. So if we take the components, so this is our x-axis, so this is our y-axis. If we take the y components of these momenta, we will get sine phi for both terms, but one is in plus j hat direction, the other one is in minus j hat direction, and indeed we see that this condition is satisfied. So we have written the energy conservation equation and momentum conservation equation. Let's move on to part C. Solve these equations and determine the energy of each photon, E photon, and the angle phi, the latter as a function of only gamma. Okay, so looking at this energy conservation equation, we see that we have gamma plus 1 mc squared is equal to twice the energy of each photon. So this tells me that the energy of each photon is equal to gamma plus 1 mc squared divided by 2. So that was part of the question. Now remember that this part is hc over lambda. So if I get rid of c from both sides, I would get the following equation. Gamma plus 1 mc is equal to 2h over lambda. That is dividing this equation by c from both sides and substituting for E photon hc over lambda. So we find that 2h over lambda cosine phi, for 2h over lambda I'm substituting gamma plus 1 mc, gamma plus 1 mc cosine, gamma plus 1 multiplied by mc cosine phi is equal to gamma m v. So we can see that the masses will cancel here, and we will obtain cosine phi to be equal to gamma times v divided by gamma plus 1 times c. Okay, now we know that gamma, the relativistic correction factor, is 1 over square root of 1 minus v square over c square. So that means 1 over gamma square is equal to 1 minus v square over c square. So we can write v square over c square equals 1 minus 1 over gamma square. That is gamma square minus 1 divided by gamma square. So we have this result for v square over c square. But we have here cosine phi equals gamma v over gamma plus 1c. Let's square this equation. So I'm going to get cosine square phi is equal to v square over c square multiplied with gamma square over gamma square plus 1, gamma square over gamma plus 1 parentheses square, the square of this term, multiplied by v square over c square, which is gamma square minus 1 divided by gamma square. So these gamma squares will cancel out, and I find that this is gamma square minus 1, which is gamma minus 1 multiplied with gamma plus 1 divided by gamma plus 1 parentheses squared, gamma plus 1 multiplied by gamma plus 1. So gamma plus 1s will cancel. So we're going to get phi, the angle, to be gamma minus 1 over gamma plus 1 square root, that's cosine phi. So this is going to be cosine inverse of this. So let me rewrite it. Phi is equal to cosine inverse of gamma minus 1 over gamma plus 1 square root. So that's what we were supposed to find. Phi only as a function of gamma. So we have obtained phi only as a function of gamma. It's cosine inverse gamma minus 1 over gamma plus 1 to the power 1/2. Okay, so in this part of the problem, we have a positron approaching an electron at rest on the x-axis with speed v, and they collide and annihilate, and two photons are created. They will be scattered at an angle phi with respect to the horizontal axis. For this situation, we want to write the energy conservation, and we have the positron energy consisting of its kinetic energy, gamma minus 1 mc square, and its rest energy, mc square, that's gamma mc square. For the electron, we only have the rest energy, mc square. This must be equal to the energy of the two photons, 2hc over lambda. Remember that we were told that these photons have the same wavelength. So they have the same energy. Now, electron momentum is 0 at the beginning because it's at rest, but the positron momentum is gamma mv. So on the x-axis, if we write momentum conservation, gamma mv, the initial momentum of the system, is equal to the final momentum, and 2h over lambda cosine phi. So h over lambda cosine phi plus h over lambda cosine phi. The y component was 0 to start with, and it is 0 for the final configuration as well. Now, if I look at this equation, gamma plus 1 parentheses, mc squared is equal to twice the energy of the photon, I obtain energy of a photon to be gamma plus 1 mc squared over 2. And for the energy of the photon, if I write hc over lambda and get rid of one of the c's here, I obtain 2h over lambda is gamma plus 1 mc. 2h over lambda is what appears in the momentum conservation. So for 2h over lambda, I substitute gamma plus 1 mc. Gamma plus 1 mc cosine phi is equal to gamma mv. Cosine phi is equal to gamma v over gamma plus 1 c. But we were told to express this answer only in terms of gamma, so we need to know what is v over c in terms of gamma. Gamma is 1 over square root 1 minus v squared over c squared. 1 over gamma squared is 1 minus v squared over c squared, so this goes to the top. And v squared over c squared is 1 minus 1 over gamma squared. Gamma squared minus 1 over gamma squared. So that's what I substitute for v over c squared here. And gamma over gamma plus 1 squared multiplied with this is equal to cosine square phi. So I'm taking the square of this equation. And gamma squares cancel. Gamma square minus 1 is gamma minus 1 times gamma plus 1. Gamma plus 1's cancel. And I find that phi is cosine inverse gamma minus 1 over gamma plus 1 to the power 1/2.